This week, it was all about getting closer to the game loop. I implemented objective system, showing UI information, and tuning up the weapon pickup system. So this was my initial implementation of the objective system, my first draft, you can say. So I thought of having a game state which defines the data table, which the data table basically contains all the objective data like the objective ID, description, and objective type. Now, there will be a bunch of enemies in the world who will register themselves to the game state. Now, the game state holds the data for objectives and also the enemy instances. Next, when the game starts, the objective system requests for all the information on world begin play of the objective system. So it gets the objective data and also the enemy instances. Next, when the enemy gets killed, the enemy unregisters itself and sends to the game state. Next, the game state broadcasts the message to the objective system, and then the objective system will then broadcast this message to the UI.
This implementation worked well, but it was not scalable as it depended on a lot of game system code. Suppose I was thinking of moving the object subsystem to another project, it would be impossible. As a result, I had to refactor the code.
This is my refactored code because of the problems with the previous implementation. We now have the objective system which acts like the central system and which does not have any references to the game code, but it's a standalone system. So the game state which contains the objective data stays as it is, but now the game state sends this data on begin play to the objective system. The same is the case for enemies who registers themselves to the objective system. They call the objective system directly and then get registered. The same will be the case when the enemy gets killed and it unregisters itself and sends that data to the objective system. Next, the UI subscribes for messages for any objective changes. For example, when the enemy registers itself, the description gets updated and the objective system would broadcast this message, and the UI catches this message and shows it in the UI. This implementation removes any tight coupling between the objective system and all the game systems in the game. Previously, the objective system was totally dependent on the game state of the game, the enemies, etc. Now it is a standalone system and there's no tight coupling or any circular dependencies between the objective system and the various components in the game. So now let's talk about objective system where I queue multiple objectives in the game. So we have a game state which currently houses the objective data table which contains data like ID, description, and type. So it would be my responsibility to fill in a unique ID, a description, and type. Type is basically telling what the particular objective is, whether it's like enemy related objective or whether it's like a hostage related objective, etc. Now, the game state also has an array which contains an objective ID. This array will act like a queue in the game. So this objective ID reads from the objective data table and gets populated here. Once it does that, the game state has an active objective which takes the top objective ID from the queue and then populates that information and sends it to the UI. Once an objective is completed, the game state checks the objective IDs and whether it's empty or not empty. If it's not empty, it pops from the queue and updates its active objective data. Once that is updated, it sends this information to the UI, which updates that information. So this is basically handled by the objective system. So whenever the game state gets updated, it lets the objective system know, which in turn lets the UI know that this got updated. Okay, so let's discuss about the problem that we have at hand. So we have a player and there are two dropped weapons which are close to each other. Each weapon has an overlap box and they are overlapping with each other. Let's consider a scenario where the player is between two overlapped boxes. Now the player presses E to pick up the weapon and he ends up picking both the weapons instead of picking one of them. So the solution to this. So when the player is overlapping, when the two weapons are close to each other, I'm doing a dot product between the player and the weapon, and then calculating the angle between the player and the two weapons which are close to each other. So in the end, the player will pick the weapon closest to him, and that will be the weapon which he'll be using instead of picking both the cases. Currently, when I approach a weapon, there's no information on the UI, like I don't know which key to press or how much ammo the weapon has. Let's address these issues. First, I created a new user widget which uses common action widget. Then I attach the widget to the weapon. I'll be hiding or showing the widget on collision box overlap. So when I'm moving away, it hides, and when I move closer to the weapon, it shows the indicator that I need to pick the weapon. Now I have to show the ammo count in the UI. As you can see, a new weapon will have a max ammo size in them. Now, when I use up ammo and drop it and pick it up again, it shows me the updated ammo count in the UI.
Thank you for watching. If you are interested in following my game dev journey, please do consider subscribing. And also, if you are interested in booking a one-on-one consultation call with me, the link is in the description and also in the bio. So see you in the next video. Bye.